We know that lenses refract light rays. When convex lens converges light rays, concave lens diverges the light rays falling on it. Power of a lens is the extent to which this convergence or divergence take place. So we can define power as the degree of convergence or divergence of light rays that fall on a lens. It means that if a lens has more power, it will deviate the light rays to the greater extent. That means if the lens has less power, then the light rays are deviated to a smaller extent. Such lenses will have longer focal length. Hence, lenses with longer focal length deviate light rays to a smaller extent, and lenses with smaller focal length deviate light rays to a larger extent. From this, we can understand that power is dependent on focal length. Power is inversely proportional to focal length. When focal length increases, power decreases. Hence, power of the lens can also be defined as reciprocal of focal length. If we want to express power in a mathematical expression, we can express as power is equal to 1 by focal length. The letter used to represent power is capital P, hence the formula becomes P is equal to 1 by F in meters. But usually we represent focal length in centimeters. In such cases, power is 100 by F in centimeters. The SI unit of power is diopter. What will be the power of a lens if its focal length is 1 meter? Yes, the power will be 1 diopter. Hence, 1 diopter is the power of a lens of focal length 1 meter. We know that focal length of a convex lens has positive sign with respect to the sign convention in spherical lens. Hence, power of a convex lens is also positive. Similarly, concave lens have a negative focal length. So, the power of a concave lens is negative. The sign associated with the value of power is only helpful to identify the type of the lens, whether it is a converging or a diverging lens. When you go for an eye checkup, your optician measure the power of the lens of your eye using a diopter meter. Later, they prescribe the corrective lenses for defects of vision indicating the powers. For example, if an optician prescribes a power of plus 2D to a person, then positive sign of power means the lens is a convex lens and the focal length f is 0.5 meter. If a number of thin lenses are placed in contact, then the resultant power of lens combination is equal to the sum of the powers of individual lenses. That means, if two lenses of focal length f1 and f2 are kept together, then the power will be p1 plus p2. When more than two lenses of powers P1, P2, P3 are placed in contact with one another, then the power of the combination will be the algebraic sum of all the powers of the individual lenses. In terms of focal length, we can say 1 by f is equal to 1 by f1 plus 1 by f2 plus etc. Hope that the concept of power of lens is clear to you. Thank you for watching the video. More contents related to class 8, 9, 10 science is available in this channel.